Next question is, a door sensor is connected to pin P11 and a buzzer is connected to P17. Write a program to monitor the door sensor which is connected to P11, and when it opens, that is when the door sensor P11 is equal to 1, then sound the buzzer. Sound the buzzer means buzzer equal to 1. You can sound the buzzer by sending a square wave of few hundred hertz. So square wave means 0, 1, 0, 1 likewise. So P11 should be analyzed. Whenever P11 is equal to 1, then P17 should be 0. After some time, P17 should be 1. Again, this should repeat as long as the door sensor, that is P11, is equal to 1. So two pins should be, uh, two port pins are taken into account. One is analyzed and the output is given to the other. So for this, again, the first statement is common to everything, include register 51.h. Since we are dealing with a delay here, because the high should be there for a particular amount of time and low should be there for a particular amount of time, we need a delay here. So like in every case, we will be calling a subroutine. So here in these cases, in this PDF, the subroutine is not written, but then it is the same subroutine which we have discussed in the delay video. So it is the same subroutine. You can write the same subroutine after this program. So void ms delay unsigned int. So we know that when you are dealing with time, you'll be declaring it as unsigned int. And here we are analyzing two port bits, which is P11 and P17. So both of these, when you're dealing with bitwise analysis, we will be declaring it as S bit, single bit. So single bit D sensor is P11 and single bit buzzer is P17. Then coming to the main program, when D sensor, what is D sensor? P11. We have declared it here. So when D sensor is equal to 1, repeat forever, while D sensor equal to 1, that is when it opens, buzzer equal to 0, delay, buzzer equal to 1, delay. So this while loop will be active forever as long as the D sensor is equal to 1. So why do we put here D sensor equal to 1? Why? That is for making P11 as an input port, input bit port. Okay. So in order to make P11 as input, we are making this equal to 1. So after this, you have to write the subroutine like in the earlier case. Void main, void ms delay unsigned bit I time, like that. Like in this particular case, let me show that to you. Okay, like in this case, you have to write the subroutine program. Voice ms delay unsigned int I time, unsigned int I comma j, for I equal to 0, I less than I time, I plus plus, for j equal to 0, j less than 1275, j plus plus. Why we are using 1275, we have discussed in another video. So like this, we'll write a subroutine here in all these cases where we are dealing with the millisecond, a fixed time delay for so many millisecond. So here also it is taken as 200 millisecond. This is taken as 200 millisecond. So the data pins of an LCD are connected to P1. The information is latched into LCD whenever its enable pin goes from high to low. Write a 8051C program to send Earth is but one country to this LCD. So data pins of an LCD are connected to P1. Information latched to the LCD whenever its enable pins goes from high to low. So LCD has an enable pin which goes from high to low. You have to send the statement the Earth is but one country to this LCD when this enable pin goes from high to low. So for the LCD data we have to write define LCD data P1. Why P1? Because it is connected to P1. And we have a enable pin, so that will be 1 bit data. So S bit, enable is denoted as EN, and that is given to P20. So you can take any pin. So here we have defined it as enable pin as P20. So P1 is the LCD data, enable pin is P20. So the character message, that is unsigned character message, is in quotes, the Earth is but one country, and we have defined another character Z, 0 to 28. Why 28? Because 1, 2, 3, then a space, so 4, 5, 6, 7, 8, 9, space 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So including the space, there are 28 characters. So 0 to 28. So these 28 characters should be sent where? To the LCD. So LCD data equal to message of Z. So here if you say LCD data is defined as attached to P1. So what happens when LCD data gets this particular message, that will be sent to P1. So when enable equal to 1, that is a high, to low pulse, that is enable equal to 0. So that is sending the 28 characters. So characters, when you count, you must count the spaces also. So write an 8051 program to toggle all the bits of P0, P1, P2 continuously with a 250 millisecond delay. Use the SFR keyword to declare the port addresses. So we are going to access the ports as SFRs. Okay, so SFR P0. So we know that when you are dealing with SFR, the memory space you are using is from 80 to FF. So P0 is 80, P1 90, P2 A0. We are defining it like that. So the special function register P0 is 80, P1 90, and P2 is A0. Now we'll define the delay, then the main program. So forever P0 equal to 55, P1 equal to 55, P2 equal to 55. So all will have the same value. Then you have to toggle. So after a delay of 250 milliseconds, you are toggling these port values. Again the delay. So after this you have to write the subroutine to make this as 250 millisecond. This also P15 on and off 50,000 times. So a similar one we have dealt with before. So since this is a single bit, you can define it as S bit. So you are using the SFR here. So we have to define the space, the memory space which you are going to use. So S bit, my bit equal to 0x95. So we can access the single bit of any SFR if we specify the bit address. So 80 to FF you can use any space. And rest we know. The logic we know, only difference is you have to use the SFR here. So if it is specified like that in the question, then you have to write like that. So in this particular case, include register 51.h is not specified. This allows us to access any byte of the SFR RAM space from 80 to FF. So if we don't use this, then you can use the SFR statement. Get the status of bit P10. So save it and send it to P27 continuously. So here SFR is not used. So you have to write include register 51.h and you have to specify these two P10 and P27 as S bit. Give two names. Here we are using the bit data type. So how do we use the bit data type? Bit, then a name, memory bit. So this is to declare the bit addressable memory. Then forever memory bit is equal to in bit. What is in bit? P10. Out bit equal to memory bit. So mem bit equal to in bit means what? Get a bit from P10, and out bit equal to mem bit means send it to P27 when forever. So for that write while one. So same kind of program we can write it in different formats depending on which is the data type you are using. So in some problems like this, especially in the case of bit addressable, when you're dealing with a single bit of the port, you can write the same program in multiple ways. So depending on whether you're going to use the bit data type or S bit or SFR, you can write it in different formats. Next, you know the logical operators. So the logical operators are AND, so double ampersand sign, or, and not is the exclamation sign. Bitwise operators, if you are dealing with single bit operation, then AND is a single ampersand sign, OR is a single one, XOR is this, inverter is tilde, shift right is greater than symbol twice, shift left is less than symbol twice. So you can see the bitwise logical operators here. So a program is given and we have to see what is happening here. So P0 equal to 35H and 0FH. Here AND operation is taking place. Here OR operation is taking place. Here XOR operation is taking place. Here NOT operation is taking place. Here shift right by 3 positions. Shift right by 4 positions. Shift left by 4 positions. So you can check it in the keel and see what is happening. Toggle all the bits of P0 and P2 continuously for 250 milliseconds. We have done this before. But in this case, the twist is that the question is use the inverting and XOR operators respectively. So initial statements are same as what we have dealt with. P0 is 55H, P2 is 55H, um, while P0 you are inverting to toggle the bits, and P2 you are XORing with FF. Okay, why XORing with FF? Uh, that is, if you're XORing with 0, um, means you'll get the same value. 0 XOR 0 is 0, 0 XOR 1 is 1. So whatever you are XOR with 0 means you'll get the other value. XORing with 1 means, suppose it is 0 XOR 1 means you'll get 1. 1 XOR 1 you'll get 0. That is, you'll get the complement. So here what we are doing is we are XORing with ones so as to get the complement. So two ways you are complementing, or you are toggling the bits. For P0 you are toggling using the invert sign, and P2 you are toggling by XORing with FF. So same process is happening. I mean, the function is different, but the result will be similar. Both in both the cases, P0 and P2, you'll get AAH. So whenever you're dealing with the delay, don't forget to write the subroutine. In this, the subroutine is not written in every case. So similar problem we have done before. Get P10 as input and send to P27 after inverting it. So we have made one as the in bit, the other as the out bit, and we have defined the mem bit as bit, and forever mem bit equal to in bit, out bit equal to invert. Okay, send it to P27 after inverting it. So you have to invert it. You have a not sign here, inverter sign here, and then send to mem bit. Sorry, out bit. So in the earlier case where we dealt with a similar problem, we were just taking the value from P10 and sending it to P27. In this case, you're inverting it and then sending to P27. Read P10 and P11 bits and issue an ASCII character to P0 0 according to the following table. So 0, 0, send 0 to P0, 0, 1, send 1 to P0, 1, 0, send 2 to P0, 1, 1, send 3 to P0. Read P10 and P11 and issue an ASCII character to P0 according to the table. So Z equal to P1. Z gets the value from P1 and Z is equal to Z and 3. Ending with 3 means 1, 1. Okay, so this is a switch statement. So you have different cases. You can write as different case. So if you AND with 3, then if you are getting Z equal to 0, then the first case P0 equal to 0. If you are getting Z as 1, then P0 equal to 1, 2, P0 as 2, 3, P0 equal to 3. So case statement, when you write, you must write a break after the case statement. When you finish the case statement, you have to write a break statement.